So what if your entire digital world could survive, well, the end of the world as we know it? Today, we're diving into a piece of tech built for exactly that kind of scenario, a future where the internet and the power grid just aren't a guarantee anymore. We're going to break down the RIOS system, which is basically a self-contained digital ecosystem that's engineered for ultimate, and I mean ultimate, resilience. Let's get into it. I mean, really think about that for a second. Our whole digital civilization, all our data, our communication, our entire economy, it all lives inside these massive, incredibly fragile data centers. They are so needy, right? They need constant, perfect power, and they need to be kept in these chilly, air-conditioned rooms. So, what happens when someone pulls the plug? What if your most important digital tools had to keep working, not just when you're offline, but in the absolute harshest conditions you can imagine? And this slide, this right here, shows you everything. On the left, that's the old way of thinking. A delicate server rack, totally helpless without a perfect controlled environment. And on the right, well, that's the new reality. It's a rugged, go-anywhere unit that gives you all the power of a data center in a box you can literally carry. This isn't just an upgrade, it's a completely different way of thinking. And this quote from the system's own field manual just nails it. It says it all. We have to stop thinking of this as just another piece of IT hardware. That's not what it is. Its real purpose is to be a tool for keeping civilization's most critical services running when everything else has completely failed. Okay, so first, let's really get our heads around the problem this whole system was designed to solve. We're talking about a world of digital fragility that, honestly, most of us just take for granted every single day. Your typical servers are completely chained to the power grid. They're vulnerable to the tiniest bit of dust or a little spike in temperature. But this new world, it's designed for what the source material calls kinetic environments. That means it's built to handle dust, vibration, even electromagnetic pulses. And maybe most importantly, it's designed so that one person can maintain it out in the field. No clean room, no team of specialists needed. Which brings us to the solution itself. The actual hardware at the core of the RIOS system. So let's take a look at how this survival tool is actually put together. What's so cool here is how every single piece of this thing is engineered for toughness. That aluminum exoshell, it's not just a case, it's a waterproof, dust-proof shield that doubles as a Faraday cage, blocking disruptive electronic signals. You'll notice there are no fans on the outside sucking in dirt. Instead, it uses a positive pressure system with heavy-duty filters. And see those 4 compute blades? They're hot swappable. You can pull one out and replace it without ever shutting the system down. And this is what field maintainable actually looks like in practice. Let's say a drive fails. You don't call a technician, you just log into the dashboard, tell the software you're going to pull the drive, wait for that solid blue light to tell you it's safe, and then you physically unlock it and swap in a new one. The system just starts rebuilding all the data automatically. No downtime, it's that simple. All right, so the hardware is an absolute tank. We get it. But that's only half the picture. Let's talk about the software and how this thing builds your own private, local cloud. Now, instead of just creating a simple Wi-Fi hotspot, RIOS creates what it calls a sovereign mesh. And this is just brilliant. If one of the physical nodes, let's say the one at the local clinic, gets destroyed, the network doesn't die. It automatically finds a new path, rerouting traffic through other nodes, or even a mobile relay like a drone to keep everybody connected. It literally heals itself. This is all about the local first idea. The cloud isn't some server farm thousands of miles away, it's right there, inside the RIOS box. There's a suite of essential apps called Project Phoenix that run locally on the machine. And that means if you lose your connection to the outside world, you don't lose your ability to communicate, or get to your files, or manage your local economy. Everything just keeps working. So what are these apps? Well, we're talking about the absolute core services you need. You've got encrypted chat for secure comms, you've got a file and document server so people can still work together, and you even have a local financial ledger running a Bitcoin and Lightning node. It's like a digital society in a box. Okay, so if you're going to run your own self-contained digital society, you're going to need a whole new way of thinking about security. And this system's approach, it's pretty wild. It goes way beyond your standard firewall. So the key tech here is something called RF fingerprinting. Forget about trying to block an IP address, which an attacker can change in 2 seconds. This system identifies the unique physical radio signal that every single device gives off. It's like a fingerprint for the device's radio. You can't fake it, you can't spoof it, and you definitely can't hide it. This allows the security protocol, which is called Watchtower, to sort every device it sees into 3 lists. The green list is for your community's known, trusted devices. The gray list is for guests. Maybe they can get limited internet, but they can't touch your local network. And the red list? That's for hostile devices, which get blocked at the physical signal level. So let's play this out. An attacker tries to brute force a password, spoofing their address to hide. The system immediately alerts you. You flip over to the spectrum view and physically pinpoint where that signal is coming from. Then you isolate that device's unique radio fingerprint, and with one command, you ban it, permanently. It doesn't matter if they change their IP address, their MAC address, their physical radio is now locked out of your network forever. So this all leads us to the ultimate test of resilience. What happens in a total collapse? A black start, as the field manual calls it. And this is where the system makes its most incredible claim. When everything has gone dark, recovery doesn't start with some complicated command line. It starts with this, a simple, laminated red card. This is the physical checklist for bringing your entire digital world back from a total blackout, one simple step at a time. And here's the promise. From a complete blackout, no power grid, no internet, absolutely nothing, to a fully functional local network with all your critical apps up and running, it takes 15 minutes. That's it. And here's how that happens. In the first 5 minutes, you stabilize power from whatever local source you have. The next 5 minutes, the system boots up and runs integrity checks on all the files to make sure everything's okay. And in those final 5 minutes, the mesh network sparks to life, starts broadcasting its signal, and brings all those local cloud apps online. Your civilization-critical services totally restored in a quarter of an hour. So as we wrap up, this whole system really forces us to ask a much bigger question. It's not just about tough hardware or clever software. It's about sovereignty. In a world that feels more and more fragile, what's the real value of actually owning and controlling your own digital existence, completely separate from the global infrastructure that we all rely on? That's a question worth thinking about. Thanks for tuning in.